Chapter 2.4, the chain rule, day 1. For review, find these derivatives. Pause the screen, prime out, and then I will come back and do these. The first one, f of x equals x squared plus 5 times 3x plus tangent of x. This is straight up a product rule problem. So our derivative will be the first function times the derivative of the second. Derivative of 3x is 3 plus secant squared of x plus the second function times the derivative of the first. And the derivative of x squared plus 5 is 2x. Our second problem, y equals 3t minus 5 quantity squared. We need to rewrite this as 3t minus 5 times 3t minus 5. And then we can use the product rule, or we can FOIL and find the derivative of the FOILed result. I'm going to use the product rule so I don't have to do an extra step. That would be first times the derivative of the second plus second. Well, it's the same function. Derivative of the first, so I'm just going to see the same thing twice. So there's my derivative. Today what we're going to look at is, instead of having to rewrite this as 3t minus 5 times 3t minus 5, we can use what's called the chain rule to do it in one step. And the chain rule involves recognizing this as two functions composed within each other. All right? We got our outside function, which is a function squared. And then we got the function that's inside. And what the chain rule says we do is we're going to do each of these derivatives separate. We're going to do each of these derivatives separate and multiply them. All right, a couple ways you can look at it. We look at the derivative each separately and then multiply, making sure we get back to the correct variable we started with. Or you can look at doing the derivative of the outside function. Here we got a composite function. Do the derivative of the outside function, keeping the inside function as it is, and then multiply that by the derivative of the inside. I'm going to use the second method here on these problems, because it has been easier for students to deal with in my experience. So let's go back to that first problem, or that second problem actually, and use the chain rule on it instead. Well, the chain rule says we're going to deal with them as two separate functions. We're going to start by taking the derivative of the outside function, the squared one. This will be dy dt because my variable is t. The squared one, the derivative of something squared is 2 times that something, powering down to 1. Well, the something inside is 3t minus 5. And then according to the chain rule, I then need to multiply that times the derivative of what's inside. Well, the derivative of what's inside is 3. And that very closely matches what we had in where we had 3 times 3t minus 5 twice. And when we found the derivative, we had 3 times 3t minus 5 twice. Okay. Let's try a few problems. Y equals sine of 2x. Now our inside function here, our inside function is 2x. So I need to leave that alone and take my derivative of my outside. The derivative of sine is cosine. So cosine of 2x. And then multiply that times the derivative of the inside. So derivative of the outside times derivative of the inside. The derivative of sine 2x is 2 cosine of 2x. Derivative of the outside times the derivative of the inside. All right, let's rewrite this one because the square root is the 1/2 power. So we got 3x squared minus x plus 1 to the 1/2 power. Not a lot of work we could do to simplify this if we wanted to use any other rule. This one you have to use your chain rule. Let's recognize the inside function. And you do not need to write this all the time. It is just helpful for beginners to write it out so you know what's your inside function, what's your outside function. Our outside function is the square root, and that we write as a 1/2 power. And using the power rule, our derivative is 1/2 times our inside function to the negative 1/2 power. Our inside function is 3x squared minus x plus 1. And then we need to multiply by our inside function. So that'd be 6x minus 1. So we got the derivative of the outside times the derivative of the inside. Right? And then keeping the inside of the function. All right. Here, our inside function, we got tangent being squared. So here our inside function is the tangent. And our outside function is the square. All right, so as we take our derivative here, the derivative of the square is 2 times that thing being squared to the first power. Now that thing being squared is the tangent of x. And the derivative of tangent x is secant squared of x. So here dy dx is 2 tangent x secant squared x. All right. Our inside function here is x squared plus 1. Our outside function is something being cubed. And the derivative of a cube is 3 times whatever's being cubed squared, usually x, but in this case, x squared plus 1 is being cubed. And then we multiply by the derivative of the inside function, and our derivative of x squared plus 1 is 2x. If you wanted to clean that up, you could say 6x times x squared plus 1 squared. This one is a little different. Not much different, and the method you use is not any different. The difference is our inside function is the sine of 4t. And if you look at that, that has a function inside of that. Inside of that is 4t. So what do you do when there's two functions inside of another function? That's basically the same idea. You're going to take the derivative of the outside. So what's the derivative of something cubed? Well, it's 3 times that something squared. And that something squared is the sine of 4t. And what's the derivative of the sine of 4t? Well, the sine of 4t has something in it. It has 4t in it. So you're going to say, what's the derivative of something sine, or sine of something? Well, the derivative of sine is the cosine of whatever's inside. In this case, it happens to be 4t. And then what's the derivative of 4t? Well, the derivative of 4t is 4. So if there happens to be 3 functions nested inside of each other, you're going to do the derivative of the very outside. Then you'll do the derivative of, for lack of a better word, the middle. And then you'll do the derivative of the very inside. So if you have 3 functions nested together, you're going to do 3 derivatives multiplied by each other. All right? So in conclusion, when you have a function inside of a function, to find the derivative, you're going to first find the derivative of the outside function. leaving the inside function alone. And then you take that result times the derivative of the inside function.